Ladies and gentlemen, welcome to the Ride Mechanic channel. How the heck are you doing today? Okay, on today's video, this is going to be a short format video. So I know my videos are typically pretty long, so I take my normal video and I chop it down to where a lot of people can finally stomach the content. So let's get into today's video.
Now get ready. Here we go.
Restraints. So what type of restraints are we going to cover today? No, not that type of restraints. So today I wanted to talk about some basic restraint systems, some of the most common rides use out there. There's predominantly two types. There's mechanical pause and locking mechanisms, and then there is a hydraulic style, which are the kind that typically when you close them, you won't be able to hear them do any ratcheting on the way down. So where does the restraint start? It starts with the seat.
This is my roller coaster chair.
So this is the first part of the restraint. Where you sit and how it holds you is part of the restraint. The purpose of these high sides right here is to keep you in under lateral movement. When the restraint closes down here and the bar comes down close like this center horn helps keep you from sliding out of the front. And then you also have a little bit of lateral support here on the sides as well. And this helps center your chest and torso side to side. Down here on the side, this helps keep your hips locked in. So as you pull the restraint down, it's going to go over your shoulders and help keep you from coming up. And then at the same time, what it does is it pins your lower body in here. All right, so let's go over mechanical restraints. Those are predominantly used across the industry because they're designed fail-safe and they're cheap to install, cheap to operate, cheap to maintain. Restraints typically consist of two components, ratchet shaft and then a ratchet paw. Basically, the shaft is a serrated shaft. It's got teeth that typically face down like this. The other side is a paw, and it's got teeth that face up like this. And in one motion, they simply just click over each other, and they go past. And every time it moves across one of those teeth, you hear those teeth go over and then snap in place. That is that ratcheting sound you hear inside the restraint. That is that as you pull the restraint down. And then those ones that you just hear like 1, 2, 3, 4 clicks out of, sometimes it's multiple paws locking on the same tooth, but next to each other. So instead of one paw on one tooth, you have two paws on the one tooth, and they both click over it and latch in at the same time. So there's redundancy in these systems as well. If the rod end at the top of the mechanism were to break, the shaft is pinned into there in such a way to where the restraint still couldn't move that much. Other dual shaft mechanisms like the SLC uses, those are more redundant because they have that entire mechanism duplicated twice. Lubrication's a really heavy factor on all this stuff. You want to take it apart and make sure it's really lubricated, nice and clean, everything's working. There's not inside restraint mechanisms, number one thing that builds up inside there is hair. There's hair mixed with lubrication and dust. And inside the restraint, you literally get hairballs floating around inside there. A different style, which is like a tooth and claw arrangement. B&M rides use this tooth and claw, and theirs are extremely repeatable no matter what. And the system is actually really easy to use. As you close their restraints, from top to bottom, you will get 8 clicks. 1, 2, 3, 4, 5, 6, 7, 8. And what that is that's 4 ledges on the inside that 4 paws are ratcheting across. But if for some reason that came undone, broke, or just for some reason didn't lock into place, it would catch that secondary. So you get that 1, 2, and then across the other one it'd be 3, 4. At 4 clicks is when the seatbelt engages on B&M rides. There's been lots of videos of people's seatbelts coming undone on the ride, and they freak out. The seatbelt is not a safety device at all. It isn't. It's not like, oh, a backup in case the restraint comes open or anything else. Your seatbelt is actually a gauge. As long as that seatbelt makes, that dimension tells us that that shoulder harness is down far enough and that passenger is now fully locked in to that particular seat. B&M in particular makes a XL restraint, and these are indicated by 2 seatbelts on those. If you look at the 2 belts, they're actually not much. They're about 10 millimeters longer. It still is the exact same setup as the other ones. You still get 1, 2, 3, 4 clicks, and then both those seatbelts latch in. Some rides don't use that. They use proximity sensors. So they say once the proximity sensor is made, we've deemed that the restraint is down far enough. That's one of those weird little issues. You always have a fight between mechanical and electrical because electrical guys can say, well, we can monitor the system so much more better and look for mechanical failure. And the mechanical guys will sit there and say, oh no, we want to make sure that we have mechanical redundancy in case the electronics fail. Why is everyone switching to hydraulic cylinders? They say, well, we're going to save you all sorts of time in labor when it comes to maintenance because unlike traditional locking assemblies, you don't have to take hydraulic restraints apart all the way, check all the individual components for wear, replace bushings, replace locking paws, or anything else like that. They fit the rider better. By that I mean, have you ever sat in a restraint where you pulled it down and you got your clicks down and then the harness was loose? Well, hydraulic restraints, they can stop at thousands of points. They don't necessarily have to stop in a predetermined area. It seems like it's a better deal all the way around. And realistically, I think they are, but they also have a flip side that has to be engineered into the equipment. So typically, the first thing you have to have is you typically need 2 hydraulic cylinders. One is for redundancy. One's your primary, one's your secondary. We made sure that every time the train came in, every seat cycled opened and closed. So we knew every single restraint came up, every single restraint went back down. If you energized the left cylinder and the restraint felt spongy, pulled on it really hard and it kind of exaggerated, but it kind of did this motion, then there was a problem with that right side cylinder. And we say lock restraints. We're actually just going to pull the power away from the left coil. And that way all the right coils lock. And then what you're doing when you're in the station checking is actually on that seat when they come by and they check the restraints to make sure they're nice and tight, they're actually only checking one cylinder. And then when they drop the bus bars, the other cylinder locks. It was a really cool process. It was really slick. We had a failure on one, and we took a small video of it, and probably not supposed to show it, but whatever. One, I don't remember which one. If you ever want proof something's working, there's your proof right there. Not a bad video for the time, right? I hope you enjoyed it. I know I enjoyed making it. All right, that's it for me. Like, subscribe, do all that stuff. It does help me out. I do appreciate it. Please stay off those air gates. If you want to see this video in its full content, there's plenty more to learn, so just click on this link right here. And if you want to subscribe, go ahead and click on this link right here. Take care.